Critical number. Find critical numbers of function f of x equals to x plus 5 whole square times cube root of x minus 4. So let me first give you significance of critical number. It basically indicates where possible extrema can occur. Right? So that is a critical number. So critical number is a point in the domain of the function where there is a possibility of having a maximum or a minimum. Right? That is what a critical number is. And at the critical number, two things can happen. One is f dash x is equals to 0 or it is undefined. So these are the two things which can happen at critical number. So when we say find critical numbers of a given function, then we are trying to find a point where for a given value of x, f dash x is either 0 or undefined. So that is what we are trying to do in this particular example. So let's find the derivative of the function. So we have f dash of x equals 2. So we'll apply the product rule here to get the derivative. So the derivative of the first term is 2 times x plus 5 times the derivative of inside function, which is 1. So we are not writing that, times second function, which is cube root of x minus 4, plus derivative of the second function. So it is to the power of 1 over 3. So we'll write 1 over 3 x minus 4 to the power of 1 over 3 minus 1 times the derivative of inside function, which is 1, times the first function, which is x plus 5 whole square, right? So that is the derivative of this function. Now we need to simplify this so that we can find at which point f dash x is 0 or undefined. So let's do simplification. We have the first term plus this is 1 minus 3 over 3, which is minus 2 over 3. So I can write this in denominator, right? And that is x plus 5 whole square in the numerator. So we get x plus 5 whole square over 3 times x minus 4 to the power of 1 minus 3, which is 2, right? 2 over 3. So it was minus 2 over 3, so we brought it in the denominator, correct? So that is what we have here. Now we'll take this as a common denominator and then further simplify. So we have 3 times x minus 4 to the power of 2 over 3. So when we multiply this by 3, we get 6. We have here x plus 5. And then we have x minus 4 to the power of 1 over 3, right? And this gets multiplied by x minus 4 to the power of 2 over 3. So when you add them up, you get x minus 4. So this is a very critical step. Go through it and try to understand it, okay? And then we have here x plus 5 whole square, right? I hope you get this. So what we're trying to do here, we are taking common denominator as 3 times x minus 4 to the power of 2 over 3. Now since it is not here in this denominator, we multiply and divide by this factor. So when we do this, then we get 1 over 3 plus 2 over 3, which is 1. And that's why we wrote here this as 1, correct? Now let's take common factors and simplify it further. X plus 5 is a common factor for us, so we can write this as x plus 5. And we're left with 6 times x minus 4 here, 6 times x minus 4 plus x plus 5 divided by 3 times x minus 4 to the power of 2 over 3. So and now we can further simplify this. Let me take to the right side and then we'll do further simplification of the same. And we have here f dash x equals to x plus 5. 6x plus x gives us 7x, right? So we have 7x, and 6 times minus 4 is minus 24, and minus 24 plus 5 gives us minus 19. So we get minus 19 here, right? Over 3 times x minus 4 to the power of 2 over 3. Now that is f dash x. Now to find a critical number, as I was indicating, f dash x should be either 0 or undefined. So let's figure out the point where f dash x is 0. So f dash x equals to 0 means numerator should be 0. That means either x plus 5 equals to 0 or 7x minus 19 equals to 0, right? So both of them gives us a number which is x equals to minus 5, and this will give us a number which is, this is minus, right? This is minus. So this will give us a number x equals to 19 over 7. So we get two numbers here for which the function's derivative is 0. That means a horizontal derivative. That's the turning point. So at a turning point, you can expect a maximum or a minimum, correct? That is what the importance of critical number is. Now, which are the points where f dash x does not exist? So it does not exist when the numerator, when the denominator is 0, right? Now denominator will be 0. That means we're trying to find when is x minus 4 equals to 0. That is at x equals to 4, correct? So that is a point where the function is undefined. So we could have extreme value here also. Think about a sharp corner, right? So that could be a point also, right? And therefore, we get our answer, and we say the critical numbers are. So we get minus 5, 19 over 7, and 4. So these are the three critical numbers, right? Now, as an added example, you can really go ahead from here and find out, do we have maximum minimum, local maximum minimum, or extreme maximum minimum at these points or not, as an added exercise? Well, this is a very important question, especially the simplification which we have done here is kind of very critical to understand. So I hope you appreciate both the concept of critical numbers and this part of simplifying radicals. And you'll enjoy it more once you go ahead. And we'll take this question again to sketch the graph and to find maximum minimum later. Thank you and all the best.